Last up in our series on OSGI Basics, we're going to be talking about the benefits of OSGI. The first big one is going to be revolving around true modularization. OSGI kind of removes a lot of the restrictions that were traditionally there in the war development style of creating portlets. We also get this salvation from jar hell. We'll kind of talk about what jar hell is, as well as how does OSGI kind of deliver us from this experience that many of us have gone through. Before we do, let's start talking about class loading. Now we know that in the Java world, class loading is done dynamically. The Java runtime is the one responsible for delivering or getting us the classes that we need. It does so by going through all of the different jar files that it has and then looking for the class that we are needing or requesting. All of this is done through class loading, right? So we have a Java class taking care of the class loading. Each object is linked to the JVM's runtime through the class loader. Each object is working in the context of its class loader, and then class loading is done in a hierarchy. Let's take a look at the parent first mode. So this is kind of the traditional way or the typical way that class loading is going to be done. First, we find the requested class in the parent class loader. So starting at wherever the parent is going to be, and then we kind of work our way up a chain. There's a specific hierarchy that's going to be taken, starting from the parent and then working its way up until it either finds it or it doesn't. This can be configurable and this can differ depending on who is doing the class loading. So a couple of different principles that we're going to lock down first. So delegation forwards the class loading request to the parent class loader. Visibility, it's a child class loader. It's the idea that a child class loader can see the parent class loader's classes, but not the other way around. And then finally, uniqueness, a class can be loaded exactly just one time. Let's take a look at an example here. So we can start down here at the bottom. We can consider the bottom part as where the parent is at. So we might have a specific application or a web app, and in it of itself, it might have jar files that it can look for the classes that it needs. If those classes are not found within the application's own context, it then goes up. So in this case, it would be Tomcat home, libext, and then whatever jar files are there. If they're not there, it goes up and up. So then it goes to Tomcat's lib folder, and then the Java libext, and then higher up, right? So it starts from the application, and then assuming things are not found along the way, it eventually ends over on the JVM side. So with class loading, things are pretty simple when we have one version of a specific library. So in this example right here, we have an application that depends on library A, and that application also depends on library B. This is very simple when there is only one version. But let's take a look at when things get a little bit more complicated. We see that the application still depends on library A as well as library B, but the application depends on version 1 of library B, while library A depends on version 2 of library B. So you can see how there might be some conflict with the application as it's pulling from version 1 of library B and library A. Since library A depends on version 2, there might be some mismatch or some discrepancy between the two that can cause us some errors within the application. This problem multiplies or grows bigger as this idea grows and grows. We have library B once again, but there can be multiple versions. We can have one application have separate versions within its own class loading context. Another application might depend on another version. And then at the Tomcat level, we might have another version. So when we're trying to class load, the proper version might not get to us. This is kind of the idea of where jar hell comes from. Oftentimes we know we're there when we see these kinds of exceptions, things like class not found, no class defined, class cast exception. So how does OSGI help us along the way? OSGI has a different style of class loading. Each bundle within the OSGI world has its own class loader, and class loading is done exclusively by the OSGI container. In the OSGI world, we ourselves have to define what our dependencies are, and we have to define what versions we're going to be using. So that way class loading is put in front of us. We are the ones who have to properly manage our dependencies rather than having to kind of blindly trust in the class loading of our application, our Tomcat server, or the JVM. So this is a diagram here of what a traditional Java web application might look like. Contrast that to the way that OSGI kind of works. So again, each OSGI application might be composed of OSGI bundles. Each OSGI bundle is declaring its dependencies, what it needs from each other or from other bundles, right? It's going to be pulling some of its dependencies as its request services from the OSGI service registry. So OSGI does not conflict with what's going on in the Java 9 world. So if you are running Java 9, just rest assured that what's going on in OSGI works as is. So no need to worry about what's happened in the Java 9 world if you are using it. What are some other benefits that come with OSGI? Right, one of them again comes from the idea of modularity. This is probably one of the biggest benefits of OSGI. Right? Each individual module, as we've talked about in previous videos, is self-contained and modular. So what we create in one bundle can be reused again and again and again. With that, the OSGI design pattern, or I should say, the patterns we use in OSGI, it's very consistent. Once you get a good footing of how to develop your applications using OSGI, it's going to be very rinse and repeat. And that's the whole idea of a good design pattern, is that we can follow it again and again and yield the same results. So let's summarize some of the key aspects, key points of the different ideas and topics we talked about. In traditional Java EE web application development, because of class loading and contextual restrictions, web applications tend to end up being monolithic and difficult to maintain. Right? The most common class loading mode is the parent first mode in the OSGI environment. Each bundle has its own class loader, but the class loader delegation is completely managed by the OSGI container. So that wraps it up for this video and this module. I want to thank you for sticking with me to the end. And until next time, I'll see you in the next video.